On to example 3 of our 3D trig problems. Biff is on the top of a 40-meter cliff looking down to the water below to 2 boats that are anchored in the water. They're not moving. He spots the sailboat at an angle of depression of 38 degrees at a direction of south 50 degrees west, and the motorboat is at a direction of south 60 degrees east and has an angle of depression of 35 degrees. How far apart are the 2 boats? Now, to set this up, we've got to understand a few things. First of all, we need to understand what this direction piece is meaning. So I'm going to look at this as a 2D problem first. So let's just talk about the water and the boats in the water. So directions, I'm going to set up my north, east, south, west. The compass rose here. And the sailboat is south, but we're veering off 50 degrees to the west. That's what this is saying right here. We're going to the south, but we're going to veer off 50 degrees towards the west. So that should look something like this with the angle between my path to the boat and south. This is 50 degrees in here. Okay, now the motorboat, I'm going to call that S, not for south, but S for sailboat. The motorboat is south, but we're veering off 60 degrees towards the east. So it means the angle between south and the path of the motorboat, that would be 60 degrees in here. So if I'm just kind of looking down onto the water from the sky, I'll put M for motorboat, the angle that the line, so Biff kind of is lined up here, but he's up in the air. I just can't, I'm not drawing that. It would be my pen hovering above my iPad. But my angle in here altogether then would be 110 degrees. All right, I'm going to take that information and I'm going to try and draw a 3D version of this diagram now. And here's what it's going to look like. It's going to look a little crazy. So below I'm going to do my 3D diagram. So here's my cliff, all right, my cliff, and down here is my sailboat in the water. So this line, I'm going to put C for the base of my cliff right here. The line S to C is laying on the surface of the water, where C to B, where Biff is at the top of the cliff. This would be the top of the cliff where Biff is, and this would be the bottom of the cliff at the water level. So that means then that this is actually a 90-degree angle in there. So perspective-wise, if I took a protractor and measured it, it wouldn't be a 90-degree angle, but I'm trying to make a perspective drawing here. Now, the motorboat is out here somewhere. Okay, the motorboat is out here. Again, that is the surface on the water. So that C to M is along the top of the water, the surface of the water. So again, this would represent a 90-degree angle in there. And now I've really messed up where C is. I'll just write maybe C inside here. And what we're trying to find is the distance between S to the letter M here. So that's what we want to figure out eventually here. What we have is that where angle C is, we know that that angle is 110 degrees. We already calculated that up here. Okay. So we have that angle 110 degrees in there. The other thing is we've got some angles of depression here. So now we have to, again, think 3D. So Biff, this is a horizontal, S to C is a horizontal line. So I'm going to draw another kind of dot in a horizontal line or a line of sight for Biff that's parallel to the water there. Now Biff has to, from his horizontal line of sight that I just drew in, he has to lower his head by an angle of 38 degrees to see that sailboat. So then by a Z pattern, because this really is parallel to this Z pattern, that means in triangle BSC, this angle down in the bottom corner would also be 38 degrees. Okay, and then on the other side, looking at the motorboat, I'm going to do that in a different color. I'm going to draw a line that's parallel to CM. Try to draw it parallel, so that is supposed to be parallel to that one. The angle of depression to the motorboat is 35 degrees. So my angles might be, again, a little off. It's distorted because it's a 3D drawing. This is my 35 degrees in there, which again, by a Z pattern means this angle at the bottom, BMC, that angle would also be 35 degrees. So lots of triangles in here. Now, The side length that we need to find is S to M, and S to M is part of triangle SCM, and the only thing I know about that particular triangle is one angle. I have no side lengths in it, and I have no other angles in it. However, if I look at my right angle triangle BSC, I have an angle in this corner, and I also know that the cliff is 40 meters tall. So I have a side length in that right angle triangle. So that would help me solve for side S to C. Okay, so I could use tan, because tan is opposite over adjacent. I could get side SC. I could use triangle BCM, the other triangle on the other right angle triangle on the other side, again with the 40, the 35-degree angle. That would allow me to solve for C to M here. And again, I would use tan because I know my opposite and I'm trying to solve for my adjacent. Okay, once I have those, then I will have two sides in that triangle that's on the surface of the water, and I could use the cosine law. So if you want to give that a shot, take some time to do that, and I'm going to draw up a solution here while you are working, and put the video on pause though so I can do that, and you're not cheating, and well, not really that it's cheating, but that you're actually trying the question on your own before you scoop ahead and copy down the solution. Okay, so I followed through with my plan. I solved for side SC, I solved for side CM, and then I used those in my big triangle that's on the surface of the water, SCM, and the cosine law to solve for how far apart those two boats are. And I got about 88.8 meters apart. Okay, two roads are intersecting at an angle of 48 degrees. A truck and a car leave the intersection at the same time, traveling on the two different roads. Cars going 80 kilometers per hour, and the truck is going 120 kilometers per hour. After 15 minutes, a police helicopter is 1,000 meters directly above and between the vehicle and notes the angle of depression to the car is 28 degrees. What is the horizontal distance from the helicopter to the truck? Whoosh, lots of things here. So you can see this is a three-dimensional problem. I've got the two roads that are on the ground intersecting at an angle of 48 degrees, the car and the truck leaving it. I've got time frames and speeds, so I can figure out a distance based on that time. I've got kilometers per hour, but then this is meters, so 1,000 meters I know is 1 kilometer. And I've got angles of depression. Whoosh, that's a lot of stuff. Okay, so let's look or think about this question. I'm going to try and draw the ground here. So the ground view, my two roads are intersecting at 48 degrees. Okay, and the car goes on the one road, the truck goes on the other. The truck is traveling faster. So this line that, let me just undo that for a second. I'm going to do it in black. This line represents the horizon. Okay, so we're thinking 3D. The two lines that I've drawn there are laying on the ground. I'm going to put the car here. It looks like the shorter distance, and the T for truck here, and I'm going to make this the letter I for intersection here. The truck is traveling at 120 kilometers per hour, so 120 kilometers per hour, but it's for 15 minutes, which is 1/4 of an hour. I could either times this by 0.25, because that represents a quarter. A quarter of a dollar is 0.25 cents. Okay, a quarter of a dollar. Or I could just divide it by 4. Okay, so whichever one makes more sense to you. Do not multiply by 0.15. Do not divide by 15, because that just, it doesn't work. It's 15 minutes out of 60 minutes out of an hour. So that should give you 40 kilometers, I believe, there. 30 kilometers, let me do that correctly. Okay, I'm better at dividing by 4. 120 divided into 4 equal pieces would be 30. The car is going 80 kilometers per hour, and again, for a quarter of an hour, 0.25 of an hour, or take 80 and divide by 4, you should get 20. So in the 15 minutes, the car has traveled 20 kilometers, and the truck has traveled 30 kilometers. All right, so in this triangle that I have laying on the ground, I could use my cosine law and get the distance between the car and the truck after the 15 minutes. Okay, so applying that cosine law, I'll just leave that as a CT. So CT squared, or you can give it a lowercase letter I, it's up to you. CT squared would equal 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 48 degrees. And then we'll throw that in the calculator. I'm going to get that the square of that is 497, provided I haven't done any miscalculations here, 0.04. And then that means that actual length when I square root it will be 22.3 kilometers. Okay, so hopefully I've done that correctly. Now, the helicopter is directly above that line of sight. So now I'm going to think the black line is the horizon. The helicopter, now that's 22.3. The helicopter is only 1 kilometer above. So our helicopter is not very far up in the sky in terms of distance here. So there's my helicopter, and that length is only going to be 1. Now I'm going to exaggerate that because it's like, I can't draw on that very well when it's so tiny. Now, I'm going to draw another horizontal line of sight. The line of sight, the angle of depression to the car, so looking down to the car, the angle of depression was 28 degrees. So that is this little angle up here, which also will match the angle in the bottom corner here. All right, so and this would make a 90-degree angle. The height, the helicopter's a 90-degree angle to the ground. So hopefully you can see all those pieces there. The 28 is the angle HC, let's call this D, HCD. And then what we want to find is D to T, the length, the horizontal distance that the helicopter is. So this length right here, the horizontal distance that the helicopter is to the truck. Okay, and again, that's a 90-degree angle in there. So what are we going to do here? Let's take a look at, I know the whole CT value. Maybe I could use my little right angle triangle CHD and solve for side CD, and then I could subtract that from the 22.3 kilometers to get the side DT. All right, so I think in that triangle, I know the opposite and I want to solve for the adjacent, so that's tan. So I'm going to put in triangle CHD, which I forgot to do that with the previous one. We were looking at, I guess that's because I only had one triangle drawn at the time, in triangle ITC. Just need an H on that and it would be quite itchy. All right, in triangle CHD, we're going to do the tan of 28 degrees is equal to 1 over CD. So that means CD will equal 1 divided by the tan of 28 degrees. And then that means that CD is equal to about 1.88 is what I got for that. So then DT, which is what I want to find, so therefore D to T will equal the 22.3 minus the 1.88, which I got to be a 20.4 kilometers. So therefore the helicopter is a horizontal distance of 20.4 kilometers from the truck. And that's the horizontal distance. And there we are. Hopefully that makes sense.